All right, so in this video, we are going to do the first of two parts of section 1.1. So in this first video for this section, we're going to cover the idea of solving linear equations in this class. So what I want to do first is kind of talk through a little bit about what a linear equation is, and then we'll talk about the methods of what we'll go through of how to solve these. So in this section, when we talk about a linear equation, a linear equation is when we have one variable in an equation that can be written typically in the following form, where by the time you're done, you should have an x term. And so the a is just a number. So you'll have some number in front of x. Typically, it has a number that doesn't have an x involved. So we'll call that b. And then usually it equals 0 or it equals some other number on the right-hand side. But what the idea is you're trying to solve for x in an equation where all you have is x's and constants. And so the end goal here is what value of x can you plug in to make this a true statement? And we're going to learn how to solve those kinds of problems here in this video. So typically solving linear equations can be very direct, and we'll see a couple of those, but sometimes it does take a few more steps than what we're typically used to. So here's kind of my three-step strategy I tell students to do when they're solving linear equations. So number one, the whole goal is we are trying to isolate the variable to one side of the equation. Now, typically this variable is x. Now, it won't always be. We'll use different letters throughout this class, but you're trying to get whatever the variable is by itself on one side of the equation. Now, it doesn't have to be the left or the right, but most students are more comfortable if we do it on the left-hand side. So I'll probably stick to that in this video. All right. When you find your answer, a solution, also known as the value of the variable, is when it's substituted into the original equation, will make a true statement. So one of the nice things about these kinds of problems is that once you find your answer, you can plug that answer back into the original problem, and it should make it a true statement. I won't do that on every single one, but I will show you on the first problem here in a minute how you can check your answer each time when you're done. Now, one of the challenges we'll run into today, and we'll talk about how to deal with it, is what happens when you're trying to solve an equation with technically decimals or fractions. And more specifically for us, a lot of things that we will do will deal with fractions in this section. What we're going to do is I'm going to teach you a technique that talks about how to clear out the decimals, or in our case, the fractions. And so when we get to our first problem that has a fraction in it, I'll start that problem off by talking about what it means to clear out those fractions in the problem. So let's begin with these two examples here. So these are typical linear equations where you can see that there are numbers and there are x values throughout. Your job is to figure out what is the x value that makes this true. So on number one, you've got 5 times 3x plus 2 equals 9 minus 4 times x minus 3. Well, when we solve an equation like this, first thing I'm going to do is I'm going to try to clean this up a little bit. So I don't really like the 5 here in the front, so I am going to distribute that through. And same thing over here. I don't really like the negative 4 out in the front by itself, so I'm going to also distribute that through. And when I do that, it should give me 15x plus 10 equals 9 minus 4x, and then negative 4 times negative 3 is positive 12. I also notice on the right-hand side, there are two numbers that go together pretty easily. So I'm going to go ahead and add those. So you'll have 15x plus 10 equals, I know that 9 plus 12 is 21, and then minus 4x. So from here, we're going to get all the letters on one side and all the numbers on the other. So like I said, typically I will put the x's on the left. So if I want to move this negative 4x from the right-hand side to the left-hand side, I have to do its opposite. So what you'll see here is that I'm going to add 4x to both sides. And so when I do that, what that allows me to do is to cancel the x's on the right. And on the left, if I add those two things together, you will get 19x. Let me put that back in purple, sorry, so the colors match. So 19x. Similarly, I need to now move the numbers to the other side. So I need to move this 10 over to the right-hand side. So the opposite of plus 10 is minus 10. So I'm going to do that to both sides and every number I see. So I'm going to cross those out. And then if I bring down my equal sign, I know on the right-hand side, 21 minus 10 would be 11. Lastly, to get the x by itself, I notice that 19 and x are multiplied together. So the opposite of multiplication is division. So I'm going to divide both sides by 19. Those cancel, and you will be left with x equals, and the only thing you have to check here at the end is, does 11 over 19 simplify or not? And in this case, it does not. There's nothing in common. So your final answer is 11 over 19. And so that is how you will solve a basic linear equation. Now, this one came out to be a pretty ugly answer. They won't always be this ugly, but we have to be comfortable working with these type of answers in this class. On number 2, you've got 1/2 x minus 3 equals 7 minus 3/4 x. So here's our first good example of we have fractions involved. And so if there weren't fractions, we could work this the same way we did the first one, but instead we're going to now learn the idea of clearing out your fractions. So my goal here is I would like to get rid of these two numbers on the bottom. And so the way to do that is you have to multiply the entire problem by what number both of these will go into. And so when you think about that, if you start with the number 2, so 2, 4, 6, 8, 10, dot, 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 and if you start with the number 4, which would be 4, 8, 12, 16, dot, 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 you're asking yourself, what's the first number they both go into? And I can see the first number in this case is 4. So what I'm going to do is I'm going to multiply everything in this problem by the number 4. And so this 4 will get distributed to everything. That's the idea of clearing out the fractions. And so if I come down to the next line, you will have 4 times 1/2 x minus 4 times 3 equals 4 times 7 minus 4 times 3/4 x. And what should happen on all of these is either the fraction should go away or you should just be multiplying basic numbers together. So if I go from left to right here, I know that 4 divided by 2 is 2. And so 2 times 1 times x would give me 2x. Minus 4 times 3 would be 12. Equals 4 times 7 is 28. And then on the last term, even better, 4 divided by 4 cancels, and you just have a minus 3x left over. Now we're back to the exact same thing we saw over here on the left. We want to put the x's on one side and the numbers on the other. So I'm going to move my x's to the left. So I need to move this negative 3x over by adding 3x to both sides. That will give me a 5x. And I need to move the numbers over to the right, and I can do that by adding 12 to both sides. Bring down the equals. 28 plus 12 is 40. And my last step here is to do the opposite of multiplication, which is division. So I'm going to divide both sides by 5. And using your calculator, this one actually does simplify. 40 divided by 5 gives you a value of 8. And so that would be the solution to number 2. It took one extra step where you had to clear out your fractions, and then it became a pretty nice problem to work out here. Since fractions are usually what gives students the most trouble, what I want to do is do a couple of more examples in this video that have to do with fractions, and that's how I'll wrap the first half of section 1.1 up. So on the next example, you've got 7/3 x minus 1/8 times 2x minus 1 equals x minus 4 over 6. Now in this one, once again, you've got fractions that you really want to get rid of. You have a 3, an 8, and a 6. And so your challenge here is figuring out what number, or what's the first number, I should say, that all three of these go into. So if you need to, you can always write down as many numbers as you need until you find it. And so I'll just write down some here. Let's do 8. And then I'll come over here and do 6. And so as I look, I'm looking for the first number that they all share in common, and it looks like that first number is going to be 24. All right? So in this case, actually, yeah, so 24 is the first number they all go into. So that tells me I'm going to multiply everything in this problem by 24. And so remember, that 24 needs to get distributed to all three of these terms. And so let's see what that ends up looking like. You have 24 times 7/3 x minus 24 times 1/8 times 2x minus 1 equals 24 times x minus 4 over 6. So there will be some simplifying here as we expected. So on the first one, 24 divided by 3 is 8. Because remember, all your fractions should end up going away here. 8 times 7 times x is 56x. 24 divided by 8 is going to give me 3. And so what I'm left with is I have a minus 3 that's still being multiplied by 2x minus 1 equals 24 divided by 6 is 4. And if I take that, that'll be 4 times x minus 4. Just like going back to problem number 1, you need to distribute those new numbers through the parentheses. So I'm going to take the -3 and multiply it through, and I'm going to take the +4 and multiply it through, which will be 56x minus 6x plus 3 equals 4x minus 16. On the left, I can put these two x terms together. So that would be 50x, because 56 minus 6 is 50, plus 3 equals 4x minus 16. And now we got to move the x's to one side and the numbers to the other. So once again, I will move the x's to the left by subtracting 4x from both sides. That'll give me 46x. And then I am going to subtract 3 from both sides, which will end up giving me -16 minus 13 is -19. I'm going to add a new slide so I have a little bit more room. And then your last step here, like we've always been seeing, is to divide both sides by 46. And so that will cancel, and you end up with a final answer of x equals -19 divided by 46. Since neither one of those numbers share anything in common, that is where you can stop on number 3. Once again, not a pretty answer, but it is through the process of clearing fractions and simplifying is how we found this desired result. So finally, to wrap up this video, let's just do one more with fractions, because like I said, this is the ones you're going to have to probably practice the most on. So for number 4, you've got x minus 4 over 2 minus x plus 1 over 4 equals 2x minus 3 over 4. Once again, you've got these fractions where I don't really want those numbers in my final problem. So I need to multiply by the first number that both of them will go into. Now, as we saw in the last problem, these are actually the exact same ones.